Now let's talk about evaluating your method. And this is something that students have a very, very hard time with in my experience. And I want to start by first highlighting some things that you should not discuss while evaluating your method. I repeat, do not discuss these things. So whenever you're evaluating, again, you should be thinking about strengths and weaknesses or advantages and disadvantages. So these are some common strengths and weaknesses that I often see students written down and do not want to see in your method evaluation. Here's a strength. The method was successful because it was organized, safe, and clear to follow. Every method should be organized, safe, and clear to follow. That's not evaluating the strength of your method, that's just evaluating whether or not you have written a method. Here's a weakness. The experiment was not successful because we didn't use our time effectively, and we didn't collect as much data as we had planned. This is not appropriate to discuss in your method evaluation because it's not evaluating your method. It's actually a weakness in the fact that you didn't follow your method. Here's another strength. We carried out the method successfully because we worked together as a group and communicated well. That's very nice. I'm glad that you did that. You should give yourself a pat on the back, but it's not relevant to your method. Working together is a general expectation in the IB. It's an ATL skill, collaboration, so that's great, well done, but it has nothing to do with the validity of your scientific research. I know I sound cold here, but I'm just being honest with you. These are the things that your science teacher does not care about when grading your work. They care about you doing these things, absolutely, but they're not relevant to your evaluation of your scientific research. Again, a weakness. The experiment was not successful because we didn't have all the materials, so we needed to make last-minute changes. That's not a problem with the method, that's a problem with your own personal organizational skills. Here's a final strength that I don't want to see in your lab report. The experiment was successful. I learned a lot about acceleration. Good, but not relevant to your method. And a final weakness, the experiment was not successful because we argued as a group and we couldn't agree on a method. I just want to emphasize, I'm not saying that these things are not important. They are absolutely important. I care about them as your science teacher, or whoever your science teacher is cares about them, but they're not relevant for evaluating your method. So please, instead of writing them in your lab report, write them in your journal, or if you do some reflections about ATL skills, approaches to learning, then write them there. What we do want to do is look at our experimental results and data and figure out what do they tell us about the strengths and weaknesses of the method. So now let's focus on what you should do. You should evaluate your method based on the results and data that you collected. And I want to revisit qualitative observations here because often students ignore these and think that they're not important, but they can be a very, very useful source for finding errors in your method. And that's the key thing here. We're looking for errors that your method may have caused in terms of the data, experimental errors. So we can have random errors and we can have systematic errors. Now, if you look at this qualitative data table, one thing that you might find is a possible explanation for the large error bars when we had a heavy mass hanging. If you read the observations for 40 and 50 grams, they mention that the cart is moving very quickly, so it's difficult to stop the stopwatch at the correct time. It was difficult to get a precise measurement with the stopwatch over a short distance. That's a source of random error because there was a lot of variation in times measured with the stopwatch at those values. For systematic error, one possible source of a systematic error could be looking at that anomaly at 10 grams. I mentioned we had this data point at 10 grams that was very small error bars, but it was not touching the trend line. So that suggests that some kind of anomalous point. And one explanation for that comes from these qualitative observations. At 10 grams, one of the observations is that the string is hanging down. It is not taut before the release. So in other words, there was some slack in the string. That's a good evidence for systematic error with that data point, because before the cart can start accelerating, the string has to be straight and tight. So that is a possible source of error in our method, because 10 grams hanging from the pulley was probably not a good choice if it doesn't make the string taut. Another source of systematic error, this is a common one, especially in physics labs. There's likely to be friction somewhere in your system. So one possible systematic error is friction in the pulley led to some reduced overall acceleration. And one final systematic error, using eyes to decide when to use the stopwatch probably led to times that were greater than reality because of human reaction time. When I released the cart and started the stopwatch, I did both of those at the same time. So I'm quite sure that I started them at the same moment. But the problem is, if I'm using my eyes to decide when to stop the stopwatch, there's some time before that message travels from my eyes to my brain, to my fingers, and stopping the stopwatch. And so that causes a systematic error with times that are larger than they should be. So I just want to emphasize here, these are all examples of issues within my method. These were things that I planned in the method that actually caused clear errors in my data, and for many of them you can actually look at the data and the error bars and identify where those happened. So for example, these large random errors, the evidence for that error is that the error bars were quite big for 40 and 50 grams. The evidence for this error of the string not being taut and affecting the acceleration of the cart is the fact that the data point at 10 grams was anomalous. It was outside of the trend line. So in conclusion, when you're looking at the strengths and weaknesses of your method, make sure that you are referring to the actual method that you have written, and make sure that you are using your data to support those evaluations.